Hello everyone, this is the homework video for homework number 21 and it was assigned 326. Alright, so what do we have to do? We have three problems. It's some exponential problem or real life situation problem. We have different scenario. For each of the following situation, use the model to calculate the output of the first 4 weeks. Okay, so then use the result to explain the situation. Is it increasing or decreasing, linear, exponential growth, or exponential decay? So now let's start with the first situation. A bee population each week is modeled by the equation y is equal to 63 times 0.6 to the power of x. What does that mean? We are told that x is the number of weeks. So this is the number of weeks. And y is the number of bees. If it is helpful for you to annotate, that's always a good idea. Okay? Now let's think about this is a equation of exponential growth function. How do we know that? Because the variable x is occurring as an exponent. Okay. Now, when we talk about exponential functions, we have two different things, right? Remember, y is equal to a times b to the power of x. That's my general exponential function. And we know that this a, the number that does not have the variable x, is the initial value or starting value. And so that means 63 is the starting value. And what is b? b is 0.6. And b is, what do we call that? We call that the multiplier. Okay, that's the number that we're multiplying over and over and over again. Okay, so to figure out the first 4 weeks of the value, we have two different ways. We could create a table, or we could do it algebraically. All right, so let's start with a table. Okay, so if we have a table, then we can say this is going to be my x, and this is going to be my y. What is y? That's the number of bees. And what's x? That's number of weeks. Okay, and so we're saying when x is 0, in the beginning, when x is 0, in the beginning, how many bees did we have? Well, we said the initial value was 63, so it's going to be 63. Okay, and we want to figure out what week 1, week 2, week 3, and week 4 value was, because we need to figure out the first 4 weeks output. Okay, but we also know that the multiplier is 0.6. So we're multiplying by 0.6. And we're multiplying by 0.6. And multiplying again to get the second value. Alright. So if we use the calculator, what we should get after multiplying 63 to 0.6 is 37.8. And if I multiply that number to 0.6 again, I would get 22.7. Okay, so that's in week 2. And week 3, multiply that by another 0.6, I'll get 13.6. And then finally multiply that again, I get 8.1. 8.2 actually. Okay, so that's what's happening. You're just multiplying by 0.6, multiplying by 0.6 to create the table. So you could do it this way. Or you could have done it algebraically using the equation. So when x is equal to 0, what is y? Y is going to be 63 times 0.6 to the power of x is 0, so it's going to be to the power of 0. And we know that anything to the power of 0 is 1. So that's just going to be 63 times 1, that's 63. when x is equal to 1, y is going to be equal to 63 times 0.6 to the power of 1. That's like multiplying 63 to 0.6, because 0.6 to the power of 1 is just 0.6, and that's going to get you 37.8 as well. And then x is equal to 2. That's going to be y is equal to 63 times 0.6 to the power of 2, which is same as 22.7. And so on. So then x is equal to 3 is going to be y is equal to 63 times 0.6 to the power of 3, which is going to be 22.7, and x is equal to 4 is going to be y is equal to 63 times 0.6 to the power of 4, which is approximately 8.16. Okay, so now that's part A. Part B, we need to be describing the situation as increasing or decreasing. Looking at the numbers, what's happening here? The numbers are decreasing. What about C? Is it exponential growth or exponential decay or linear? Well, since the number is, we have a number being multiplied over and over again, same number being multiplied over and over again, it is exponential. And since the numbers are going down, it is exponential decay. Okay, so that was number 1. Let's go on to number 2. The bee population this week is modeled by the equation y is equal to negative 6x plus 63, where x is the number of weeks and y is the number of bees. Okay, so now looking at this equation, does it look like an exponential equation? No, it's not. The variable x is now occurring as an exponent. Okay, what does it look like? It actually looks like y is equal to mx plus b form, and this is linear equation. So what do we know? M is, so we know that m is the number multiplied by x is negative 6. So m is negative 6. And what is b? B is the number that's being added. So the b is positive 63. Okay, so then we know that we're starting with 63 and we're adding negative 6 each time. We can do this algebraically, or we can do it as a table. Okay, so let's do it as let's do algebraically first. Okay, so we know that y is equal to negative 6x plus 63. That's the equation that we were given. And so now to figure out what is week 0, when we're talking about week 0, x is going to be equal to 0. So then y is going to be negative 6 times 0 plus 63, which is anything multiplied by 0 is 0, plus 63 is 63. Week 1, x is equal to 1. So y is going to be equal to negative 6 times 1 plus 63. So that's like 63 minus 6. So that's going to be 57. And week 2, x is equal to 2. Y is equal to negative 6 times 2 plus 63, which is same as 51. And then week 3, x is equal to 3 and y is going to be negative 6 times 3 plus 63, which is 45. And then week 4, x is going to be 4 because x represents the number of weeks. So y is going to be negative 6 times 4 plus 63, which is going to be 39. Okay, if I was to create a table instead, I could have just gone from this information here and said, okay, I know my x and y. I know that in week 0, or the y-intercept when x was equal to 0, y was positive 63. And then from here, I know that the numbers are going to decrease, or I'm going to subtract 6 from each number, or the previous number. Okay, so week 1, after I subtract 63 from 6 from 63, that's going to be 57. Week 2, after I subtract 6 from 57, 51. Week 3, after subtracting 6 from 51, is going to be 45. And then finally week 4 is going to be 39. So by week 4, I am going to have 39 B's, as opposed to problem number 1, I had 8 B's after week 8. So that's the A part. What is B? Okay, is it increasing or decreasing? Are the numbers increasing or decreasing? It's decreasing. What about, is it an exponential growth, decay, or linear? We said this was linear. Okay, and then finally, let's go on to the last. Okay, for this one, let's just do algebraic. Okay, so now we're going to create y is equal to 63 times 1.06 to the power of x. What does that mean? Again, we are starting with 63. But the multiplier in this case is 1.06. That means it's a number bigger than 1. When you multiply a number bigger than 1, the number is going to get bigger. Okay? So straight away, we know that this is going to be B. It's going to be increasing. And C, it is going to be exponential growth. Okay, and we just need to calculate the first 4 weeks. Okay, so we can do it. Now let's talk about the multiplier. If this is multiplying by 1.06, what is the percentage increase of B's? We could represent this as 6% increase. So this question could have very easily said the bee population increases by 6% each week. Okay, if that was the case, the equation that will go with this problem would be y is equal to 63 times 1.06 to the power of x, provided that we are told that the initial value is 63. All right, you know what? Let's do the table because that's going to be easier. So x and y, when x is equal to 0, that's week 1, or week 0. We're going to start with 63, and week 1, we are going to multiply that number by 1.06. And when you multiply that number by 1.06, we should be getting 66.8. Okay? And when we multiply that number again by 1.06, I'm sorry, and we should get 70.8. That's week 2. Week 3, we should get 75. And week 4, we should get 79.5. Okay? So that's after we multiply by 1.06 each week. And that is it for the homework video. Okay? I hope it makes sense. Thank you for watching.